Today I will discuss again with you next topic of limits, under which we discuss mainly existence of limit. What do you mean by existence of limit? I have already told you in very detail, but in this class I will again discuss some another way and with some examples, because in the previous class we discussed about existence of limit with the help of only theoretical portion, not with examples. In this class mainly we focus some standard problems. First of all, I want to recall something which is that become important for you in this lecture. In the previous class, I have already told you, if you have to find limit extends to a fx, then how can you find it? Then I suggest you there are two ways. Firstly, you can directly solve by this way. You can directly solve by this way, by directly putting if it exists directly. Sometimes if given is a rational function as a numerator by denominator, and it forms 0 by 0, infinity by infinity, in that case you can remove that factor which common in numerator and denominator. After it you can directly put and finally you get answer. But there arises a simple question. That process will be direct method, but here I will discuss existence of limit. Means that in which condition I am able to find the limit, or in which condition I am not able to find limit. Before solving problems, we have to always check about existence of limit. Sometimes in the question directly they ask to you find the limit. This is another matter. But if they ask to you, you have to evaluate the limit. Then in that case you have to also consider about existence of limit. If limit does not exist, you can't find the limit. So any problem before solving limiting problem, you have to check always the existence of limit. Without checking the existence of limit, you can't find it. So I want to give you some idea to find or to check out the existence of limit. Suppose that this is a problem, and how can you solve? I have already told you, if limit exists, it will be same as limit x tends to 0 f a plus s, and it is also equal to limit x tends to 0 from left hand side, from right hand side by this way, and left hand side by this way. That will be f a plus s, where h is very very small positive quantity. This is the actual concept of existence of limit. Now I want to tell you in which condition limit exists or not exist. Right? Limit extends to fx exists if limits, that means this is LHL, sorry RHL, this is RHL. If RHL is equal to LHL, RHL means that right hand limit of fx at x is equal to a, and LHL means that left hand limit at x is equal to a. When you get LHL and RHL the same, then you say limit exists. Now I want to tell you, while you are determining the value of limit, you can find the limiting value by any way. By directly by this way, directly this way, directly this way. Most of the case, I am solving problems. I solve problems by this way. While I think given problem is more complex, then for simplifying we can use this formula. You can also this use, but I don't use because while solving it becomes a minus s. Here there is a minus s, it becomes a minus s, and you have to put the value of a minus s. It's just like a minus and I don't like. So I don't use this. But you can find also by this way. Suppose that I want to give you a simple problem. So you have to remember it. If in any questions they ask to you have to check the existence of limit. Then check LHL and RHL. If RHL is equal to RHL, then you can say that limit exists or not exist. Now, some questions. Suppose that I want to, before I start a question, I want to give you some idea. Do you know modulus function? This is basic things. Fx is equal to mod x is equal to x when x is greater than 0 and is equal to minus x when x is less than or equal to 0. You can take it. When fx is equal to modulus x for all x belongs to real number, fx is equal to modulus x will be defined as x is mod x is equal to x if x is greater than or equal to 0 and mod x is equal to minus x when x is less than 0. You have to remember it. Now, I want to tell you, suppose that I want to give you a simple problem. Fx is equal to x plus 2 when x is greater than 2. Fx is equal to x minus 2 when x is less than 2. Now, I want to tell you, find f 2.1 and f 1.99. How can you solve this problem? There are fx is split into two functions into different cases. When x is greater than 2, then fx is equal to x plus 2. When x is less than 2, then you get fx is equal to x minus 2. Now, then how can you find f 2.1? In which interval, in which function we put x is equal to 2.1, in which function we put x is equal to 1.99? Now, I want to tell you some simple concept. Here, x is equal to 2.1, just a greater than 2. Then here x is greater than 2. Then you have to choose function this and you have to put the x is equal to 2.1 in this function. That will be 4.1. And if you have to find the value of f 1.99, then you have to check out 1.99 in which interval does it lie? In which interval does it lie? It lies in x less than 2. Then you have to put x is equal to 1.99 in this function. This is basics because you are solve while I am solving problem, then this concept comes. If you have no idea, then you face many kind of problem. Now it becomes minus 0.01. This is your answer. Now I am starting some problems which is related to existence of limit. Before existence of limit, I want to give you some idea. Suppose that I want to tell find limit x tends to 2 x plus 2. X plus 2. I give you this problem and you have to solve. How can you solve? I think you know that you can solve directly limits at 2 plus 2 is equal to 4. In which case, when you see that after putting the value of x is equal to 2, it gives a particular value, not a infinity minus infinity, infinity minus infinity, 0 by 0. Then you can directly put. But there is also another way by which you can solve. How? As you know that x is equal to x plus 2 is a polynomial function which exists. That means this is a polynomial function. Here at x is equal to 2 limit exists. So you can find also by another way. How? Here, as you know that I have already told you, limit x tends to a fx is equal to also limit x tends to 0 f a plus h. Here a is equal to what? 2. So you can find also limit x tends to 2 fx is equal to limit x tends to 0 f 2 plus x, because if you solve this problem by RHS, then it becomes a plus h. A plus h, here you take a is equal to 2, so you write a 2 plus h. Here now if you put in place of limit x tends to 0, if you put x is equal to 2 plus h, f 2 plus h means that you have to replace x in given function by 2 plus h. That means here function is x plus 2. Fx is equal to what? X plus 2. That means if fx is equal to x plus 2, then you have to replace x by x. 2 plus h, simply write 2 plus h plus 2. 2 plus h plus 2. Now it becomes limit x tends to 0 from right hand side. 2 to 4 plus h. Now you have to put h tends to 0, then it becomes 4. This is the second method by which you can solve also. There will be also another method which is called left hand limit. LHL, this is called RHL. Now if you find LHL, limit x tends to 2 from left hand side fx, then you can solve it. Limit h tends to 0 from left hand side f2 minus h. Because in case of LHL, if we take LHL, it becomes also LHL, and as in this way you can find also. In this way, there is simple logic. You have to replace in fx x by 2 minus h. Now you have to put in place of x 2 minus h, then you get limits h tends to 0 from left hand side 2 minus h plus 2. That will be limits h tends to 0 from left hand side 4 minus h. If you put h is equal to 0, then you get 4. You observe, if you solve by direct method, you get answer 4. If you solve by RHL, you get answer 4. If you solve LHL, you get answer 4. In each case, you get correct answer and is equal to each other equal. So, I want to tell you again, if limit exists, then LHL is equal to RHL. And you can solve by any way. If you have any trouble to solve by this way, you can solve by this way. You can solve by this way. But I solve most of the time by using RHL, because here it becomes plus, here it becomes minus. Minus in function, putting minus while you are getting trigonometric function, it becomes minus formula. Sometimes students having no remember, students could having no idea minus formula, so I don't use this types of LHL. But this is also important because while you are checking the existence of limit, it was very important. Now I want to take examples for you. Examples will be, in this problem it said if fx is equal to, if fx is equal to x square minus 1, x square plus 1, here x is less than or equal to 1, here x is greater than or equal to 1, sorry, greater than 1, does limit x tends to fx exist? There is a question, does limits x tends to 1 fx exist? Now, how can you check existence of limit? First of all, you have to find RHL. Again, you have to find LHL. If LHL is equal to RHL, you get, then you can say that limit exists x is equal to L. If you do not get LHL is equal to RHL, then you can say that here the limit does not exist. So firstly, I want to find it. Right, LHL of fx at x is equal to 1 will be limits x tends to 1 from left hand side fx. Can you write? Now, limits x tends to 0 from left hand side f1 minus h. Now, there arises a simple concept. Be careful here. This is f1 minus h. What is the value of 1 minus h? Slightly less than 1. Slightly less than 1. Why? Because h is a very, very positive, small quantity. But it is subtracted from 1. H is subtracted from 1. 1, if you subtract anything from 1, that means it reduces to 1. It is slightly, according to this problem, if h is very, very positive, small quantity, in that case 1 minus h is slightly less than 1. That means you have to choose, define those functions which is defined for less than 1. That means slightly less than 1. Now here you see that here x is there are two functions. X is greater than 1. You do not choose this function. Why? Because here there is given x is greater than 1. But in this question you see that here x is equal or x is less than or equal to 1. So you have to choose this function. And in this function, x is replaced by 1 minus h. So we have to write limit x tends to 0 from left hand side. X is replaced by 1 minus h. 1 minus h whole square minus 1 is equal to, do you write, is equal to limits x tends to 0 from left hand side. After it you have to expand it. 1 square plus h square minus 2h minus 1. 1 and 1 cancel. And if you put h is equal to 0, h is equal to 0, then you get what? 0. Because h square minus 2h, 0 square minus 0 will give 0. This is LHL. Now you have to find RHL. RHL of fx at x is equal to 1. If you find RHL of fx at x is equal to 1, what do you get? It will be limits x tends to 1 from right hand side fx, which will be limit x tends to 1 from right hand side. That means you can write x tends to 0 from right hand side f1 plus h. That will be limit. Now here you observe that f1 plus h. That means x is equal to what? Slightly greater than 1. Then you have to choose this function, because here is it says that according to question fx is defined by two ways. When if you take x greater than 0, then you have to choose fx is equal to x square plus 1. If you say x is equal 1 or less than, that means x is greater than, less than or equal to 1, then you have to choose function fx is equal to x square minus 1. So you get limit x tends to 0 from right hand side. You have to replace in fx x by 1 plus h. That means here you have to replace x 1 plus h whole square plus 1. That will be limit x tends to 0 from right hand side 1 square plus h square plus 2h plus 1. If you calculate, you get limits h tends to 0 from right hand side 2 plus h square plus 2h. If you put h is equal to 0, what do you get? 2. How? Because it will be 0, it will be 0. Here 2 is a constant, so you get 2. Here, now you have to write here, we observe that LHL is equal to not RHL. By language you have to write in the detail, you have to write since LHL of fx at x equal to 1 is not RHL of fx at x equal to 1. So, limit x tends to 1 fx doesn't exist. This is the way by which we check existence of limit. I think you understand. Again, I take next problems for you. In the next question, it is given that 60. Find limit x tends to 0 fx. Find limit x tends to 0 fx and limit x tends to 1 fx, where fx is equal to 2x plus 3, 3 into x plus 1, x is greater than or equal to 0 and x is greater than 0. You have to find this limit and this limit. But I want to tell you again, as I have told you, firstly check out does your limit exist or not. Does the limit exist or not? Thereafter, if limit exists, then obtained value will be its limiting value. If limit doesn't exist, then you have to check out. Now, solve it. Here, in this problem, x approaches to 0 and here x approaches to 1. Firstly, solve this way. Limit. Now I want to write directly. Don't write LHL of f x at x equal to 1. You have to write directly. I want to write LHL is equal to limits x tends to 0 from left hand side fx, because here it will be 0. If you find the LHL, what do you get? X tends to 0, f0 minus h. That means less than 0, that means you have to choose this function. Now you have to put this function limit x tends to 0 from left hand side 2 into x, that means 0 minus h plus 3. Now you have to put in this problem limits x tends to 0 from left hand side 0 minus 2x plus 3. If you put x is equal to 0, then what do you get? Okay. That means LHS is equal to 3 and RHS is equal to, and you have to write RHL of fx at x is equal to 0. There is no end of space, so I don't write it. RHL is equal to limits x tends to 0 from right hand side fx. Will be x tends to 0 from right hand side f0 plus x. Now it is slightly greater than 0. In that case, you have to choose this function. So put it x tends to 0 from right hand side 3 times x is replaced by 0 plus x. X is 0 plus x plus 1. Now if you put x is equal to 0, then what do you get? 3. Here you observe that LHL and RHL at x is equal to 0 of fx, you get 3. Since LHL is equal to RHL at x is equal to 0, so limit exists and equal to what? As you know that obtained LHL and RHL will be a limiting value, that means 0, 3. This value will be limits. Now second problem, they ask to you, you have to find, I think this problem is done. Now I want to find the limits x tends to 1, that means you have to find limit x tends to 1 fx. Now you have to take LHS from left at 1, then you have to write x tends to 0 from right hand side, that means 1 minus x. Here 1 left hand side, sorry, at 0. Now there is a simple problem for you. Here x is less than 1 minus x. 1 minus x means 1 minus x. Now 1 less than 1 means that in which interval 1 minus x lie? If you see x is greater than 0, this is slightly less than 1. If it is slightly less than 1, suppose that 0.999, in which defined function 0.99 lie, definitely you will take this because x is greater than 0. All positive number comes in this for this function. So you have to choose this function and you have to replace x by 1 minus x in this function. So it will be 3 into 1 minus x plus 1. If you calculate it, you get 2 minus x, that means will be 3 to the 6 minus 3x. Now 3 to the 6 minus 3x. If you put x equal to 0, you get 6. If you find RHL, you get at 1 fx 1 plus x. Now 1 plus x. Now there is again a simple problem. What? There is a simple problem. Sometimes the student confused about this problem. I have again x is equal to 1 plus x. That means slightly greater than 1. Then which function is chosen? Because slightly greater than is in this function. So you have to choose this function. That means x is equal to 1 plus x. 3 into x will be 1 plus x plus 1. That means if you put again x is equal to 0, you get 3 to the 6. It is your RHL function. Now we have to write since LHL is equal to RHL at x is equal to 1. So limit x tends to 1 fx exists and equal to 6. Now I again take next problem 17 for you. In the next problem 17, in 17 they ask you let fx is equal to x plus 2 and cx square. X plus 2 is for x is less than or equal to minus 1 and it is x is greater than minus 1. Find c if limit x tends to 1 fx exists. It is also very easy problem for you. In this question they ask to you if limit x tends to 1 fx exists, then you have to find the value of c. As you know that c since limit x tends to 1 fx exists, if limit x tends to 1 fx exists, then LHL of fx at x is equal to 1 is equal to LHL of fx at x is equal to 1. Then implies that definitely you can say that limit h tends to 0 f1 minus h is equal to limit h tends to 0 from right hand side f1 plus h. I have written directly. Here in this problem there is given limit exists. If limit exists, then left hand limit will be right hand limit. That is LHL is equal to RHL. That implies that limit h tends to 0 from left hand side f1 minus h. Now you have to choose the proper function. It is less slightly. It is slightly less than 1. It is slightly less than 1. 1 minute wait. I want to see question 1 or minus 1. I think there should be minus 1 in this problem. There should be minus 1. If 1, no problem. If there is minus 1, there should be minus 1 according to me. By mistake, I have written 1. There should be minus 1. Now, that is a simple problem for you. In this question, they say to you, limit exists. If limit exists, then LHL is equal to RHL. Now you have to choose proper function. It is slightly less than minus 1. It is slightly less than minus 1. Slightly less than minus 1. X is less than or equal to minus 1 is equal to x plus 2. Now you have to replace x by minus 1 minus x in this function. So it will be minus 1 minus x plus 2 is equal to limit h tends to 0. Here it will be slightly greater than minus 1. In which function we choose slightly greater than minus 1? For all x is greater than minus 1. So you have to choose minus 1 plus h. Now you can write c into minus 1 plus h whole square. Now you have to put that implies that if you put in 0 in this function, you get 1 is equal to, if you put after manipulating limits, I think it not visible for you. So I want to write it above. That implies that it will be 0, 2 minus 1, that means 1 is equal to limit h tends to 0. Now you have to expand it, then you get c into 1 square plus h square minus 2h. Now you have to put h is equal to 0, then you get c equal to 1. 1 because it will be 1 and will be, if you put h is equal to 0, it will be 0, c into 1. So c equal to 1. I think you understood. All problems are very easy. Only you have to find left hand limit and right hand limit. If left hand limit and right hand limit both will be same, then you will say limit exists, otherwise not exist. Example say t. Let fx is equal to a function is defined in 3 parts. A plus bx if x is less than 1. 4 if x is 1. B minus ax if x is greater than 1. And if limit x tends to 1 fx f1, and if limit x tends to a fx is equal to f1, what are the possible values of a and b? What are the possible value of a and b? This is a good problem. Learning. In this problem, it says to you limit x tends to a1, fx is equal to f1. f1 is equal to 1. That means at x is equal to 1, what is the value of fx? At x is equal to 1, fx is equal to 4. So there should be 1. Now you have to, according to this question, you have to find the a and b. There are 3 parts, that means a1, 2, 3 parts. As you know, this is constant, and you have to find the value of a and b. Definitely there exist 2 equations at least, then you can find a and b, or not it becomes more complicated for you. So definitely you have to check left hand limit and right hand limit both. Since now it may be equal to LHL, you can say that limit, it may be a limit x tends to 1 fx is equal to also limit x tends to 0 from left hand side f1 minus x. Then it is slightly less than 1. In that case, you have to use this function, and in this function you have to replace x by 1 minus x. X is replaced by, then you can write limit x tends to 0, a plus b into 1 minus x. Now you have to put x equal to 0. What do you get? It will be a plus b. About this problem, it is already told f1, it is also equal to f1, and f1 is equal to what? 4. So you can write here, it will be f1, and it is equal to 4. It will be question first. Now, this is also equal to RHL. That will be limit x tends to 1 from right hand side fx. That will be limits x tends to 0 from right hand side f1 plus h. Now you have to choose the proper function. According to this question, x is equal to slightly greater than 1. If x is slightly greater than 1, then you have to choose this function that you can write. Limit x tends to 0 from right hand side, x is replaced by 1 plus h, then you can write b minus a into 1 plus h. Now you have to put the value of x is equal to 0, then you get b minus a, which is also equal to 4, because in this problem already told this limiting value of f(x) at x is equal to 1 will be same as f1 in both cases, because it is limiting value. So it may be either LHL or RHL, because I have already told you limiting value of function will be same as LHL and RHL. So I find 1 by 1 LHL and RHL and equate by 4. So here we get a plus b is equal to 4 and a minus b is equal to 4. After adding, you get 2a is equal to a. So a is equal to 4. If a is equal to 4, then b is equal to what? 0. That means possible value of a and b will be a is equal to 4 and b is equal to 0. This is the concept behind this problem. Now we take again next problem for you. In the next question, anyway, they asked you for what integer m and n both limit x tends to 0 fx and limit x tends to 1 fx exist. Write first question for what value of m and n does both limit x tends to 0 fx and limit x tends to 1 fx exist if fx is equal to mx square plus n, x is less than 0, and x plus n, x is greater than 0 but less than or equal to 1, and x cube plus n if x is greater than 1. You have to find the value of m and n such that both limiting value exist. That means now you have to check one by one. If limiting value of fx at x is equal to 0 exists, then LHL of fx at x is equal to 0 and RHL of fx at x is equal to 0 will be same. So, right, since limit x tends to 0 fx exists, so limit x tends to 0 from left hand side of fx will be same as limit x tends to 0 from right hand side of fx. Then implies limits x tends to 0 from left hand side f0 minus h will be same as limits x tends to 0 from right hand side f0 plus h. Can you write? That implies that limits x tends to 0 from left hand side 0 minus h. 0 minus h means that what? You have to choose that function which is defined for the x for that value of x which is slightly less than 0. In which category of function x is slightly less than 0? You observe here in this function x is slightly less than 0, then you have to choose this function. So you have to replace x in this function by minus x. You can ignore 0. Minus x, that means m times minus x whole square plus n. Very good. Limits x tends to 0 from right hand side. If you take, I think, is it visible or not? Here I have written m minus x whole square plus n. I want to write here so that you see. Limit x tends to 0 from left hand side. M into x is replaced by simply minus x whole square plus n. This is x and this is n. Is equal to limit x tends to 0 from right hand side. F 0 plus h. 0 plus h means that it is slightly greater than 0. That means slightly greater than 0. Here 0 plus h means that slightly greater than 0, not a very large 0. Slightly means that if 0 plus h, that means suppose that 0.999, sorry, 0.001. In that case, in which function we choose? Definitely nx plus m, because x is greater than 0 and less than 1. So function will be nx plus m. That means x is replaced by h. So you can write nx plus m. Here it will be n and it will be h. Now you have to put h is equal to 0, then you get n is equal to, if you put h is equal to 0, you get n. That means from this expression you get n is equal to m. This is your equation first. You get n is equal to m. Now in this problem there is also given another condition. Limit x tends to 1 fx also exists. In that case you can write second part will be limit x tends to exist. So you can say that here it will be also set. If it will be set, then its addition of fx at x equal to 1 will be 1 minus x. Sorry, I have written here negative. So you have to get 1 minus x and 1 plus. That means it will be 1 plus x. Now you have to choose again function. Here x is equal to 1 minus x. If you take x is equal to 1 minus x, that means x is slightly less than 1. So in which function you choose? Which function will be chosen? Because x is slightly less than 1. Right? X is slightly less than 1. That means you have to choose an expression. Now you have to replace x in this function by 1 minus x. Then it will be n into 1 minus x plus n. And it will be right hand side. It is slightly greater than 1. If it is slightly greater than 1, then you have to choose this function. Why you choose this function? This is n. This is also n. Then if you choose a slightly greater than 1, then you have to choose this function. And in this case it will be n times 1 plus h whole cube plus m. Now you have to again put, if you put, already you get what? N is equal to m. Write the equation first. And in this case, if you put x is equal to 0, you get n plus m in the left hand side, and in right hand side, if you expand it using a plus b whole cube formula, then you get aq plus bq plus 3a square b plus 3ab square. In that case, you finally get this will be also n plus m. This will be also, because 1 plus h whole cube, then you again get 1 plus h, that means n plus m. That implies that n plus m is equal to n plus m. Now you observe that what? Now you observe that what? In both conditions, both will be same. In both conditions, both will be same. So what can you say? So for all n and m both exists. That means this limiting value and that limiting value both exist for all n and m. Have you understood? Okay. Now we take next example for you. 20. 20 will be, let f be a function defined by fx. Let f be a function defined by fx. fx is equal to x by mod x. X is equal to node 0. When x is equal to node 0, then you can choose fx is equal to x by mod x. But if x is equal to 0, then you have to choose fx is equal to 0. This is the way by which function is defined. What can you say? What is the meaning of this word? Here it says that if x is equal to 0, then fx is equal to 0. If x is equal to not 0, means that either x is 0 greater than 0 or x is less than 0. If x is greater than 0 or x is less than 0, then you have to choose function x by mod x. If x is equal to 0, then you have to choose function fx barabar 0. This is the way. Now, in this problem, it says to you, does, now they ask you, does limit x tends to 0, fx exist? You have to check out, does it exist or not exist? See here, firstly, you have to write here, limit x tends to 0, fx exists. If I double f means that if and only if. I double f if means that or if and only if. Limit x tends to 0 from left hand side fx is equal to same as limits x tends to 0 from right hand side fx. According to this problem, as you know that it will be limits x tends to 0 from left hand side f0 minus h is equal to limits x tends to 0 from right hand side f0 plus h. Now, that implies limit x tends to 0 from left hand side f0 minus h. You have to choose now function. How can you choose? It says that you have to choose that value which is slightly, or you have to choose that function which is defined for that value of x which is slightly less than 0. You know that at exactly value of x is equal to 0, we choose that x is equal to 0. But when if you go x is greater than 0 or less than 0, then you have to choose function x by mod x. That means that you have to replace x by minus x. So let's say we will limit h tends to 0 from left hand side minus h by minus mod minus h is equal to limit h tends to 0 from right hand side and it is slightly greater than 0. In that case, we again choose x is equal to fx is equal to x by mod x, that is x by mod x. What will be said? Now, manipulate it. It will be modulus of minus h will be h, so it will be h is cancel, that will be minus 1 and that will be 1 because mod h is equal to here mod minus h will be h. Minus h by h will be minus 1 and h by mod h it will be, that means mod h by 1, mod h is equal to h. In that case, you get h by h, that will be 1. So you get minus 1 by is equal to 1, which is not true, which is not possible. So limit x tends to 0 fx doesn't exist. What can you say? Limiting value of fx at x is equal to 0 doesn't exist. Now we take again next problem for you. Next problem will be 21. 21 will be let f be a function defined by fx is equal to 5x by mod x minus 2x square when x is equal to not 0 and it will be 0 if x is equal to 0. Then you have to check at x is equal to 0, does limit exist or not? Does limit x tends to 0 fx exists? You have to check. How can you check out? It is also very easy. Simply write limit x tends to 0 fx exists. if and only if limit x tends to 0 from left hand side fx is equal to limits x tends to 0 from right hand side fx. That implies that you have to find, you can write limit x tends to 0 from left hand side f0 minus x is equal to limit x tends to 0 from right hand side f0 plus h. That implies that now you have to replace fx in fx x by 0 minus x. That means you can ignore it 0. You can ignore 0 and you have to put in fx simply minus x. Now you have to choose function. It says that you have to choose x is slightly less than 0. Function is categorized into two parts. When x is equal to 0, then you have to choose fx is equal to 0. When x is equal to not 0, what is the meaning of x is equal to not 0? It is it represents. It says x is equal to not 0, then it becomes 5x by mod x minus 2x square. Means that x is equal to not 0 means that either x is equal to 0 or x is less than 0. Means that in case of x is greater than 0 or less than 0, in both cases you have to use this function. But in case when x is equal to 0, you can't use this function, you have to use this function. Now you have to write left hand limit, that will be x is replaced by minus h. So directly you can write limit x tends to 0 from left hand side. X is replaced by simply minus h. So you can write 5 into minus h divided by mod minus h minus 2 into mod minus h whole square is equal to limit x tends to 0 from right hand side 5 into h divided by mod h minus 2 h whole square. That implies that limit x tends to 0 from left hand side. It will be minus 5h divided by mod minus h will be h minus it will be 2h square is equal to limit h tends to 0 from right hand side 5h divided by it will be h mod h can be written as minus 2h square. Now you have to write it. That implies that if you take common h in denominator, that implies that limit h tends to 0 from left hand side, you can, if you take common h, then h can be cancelled. In both terms you get minus 5 by 1 minus 2 minus 5 by 1 minus 2h is equal to limit h tends to 0 from right. If you take again common h, then you get 5 by 1 minus 2h. Can you write? Now you have to put the value of h. If you put h value of h, you get what? Minus 5 by 5, which is not possible. Which is not possible. Which is not possible. So limit x tends to 0 fx doesn't exist. Doesn't exist. I think you understand this. In this problem, nothing. You have to. I think there is a simple problem. Check out the existence of limit. You have to choose function. How do we choose function? Otherwise, everything becomes very easy for you. Similarly, I take next example for you. 22. 22. Example 22. In 22, it asks to you, let f be a function defined by fx. Let fx be a function defined by three parts. Fx is equal to mod x plus 1 if x is less than 0 is equal to 0 if x is equal to 0, mod x minus 1 if x is greater than 0. There are three cases. For what value of a does limit x tends to f exist? In this question, they ask to you for what values of a does limit x tends to a fx exists. For what value of a does limit exists? Now, in this problem, they say to you for what value of a does limit fx extend to a exist. There is given only which value of A? I think I have no idea about A. What is A? What is A? It may be, if suppose that it is 0. For 1 minute, suppose that it is 0. In that case, RHL will be this and LHL will be this function. Suppose that for 1 minute A is negative. In that case, suppose that A is equal to -1. In that case, LHL will be same and RHL will be same. That will be mod x plus 1. Suppose that A is equal to any positive number 5. In that case, RHL both cases same. Definitely, you have to, if you want to solve this problem, you have to arise 3 cases. In 3 different cases. But I want to tell you a very important point. Whatever they ask to you existence of to check out existence of limit, then there is in most of the cases there is single doubt point at which we have to check out. There will be common point, that means 0. Otherwise, everywhere a limit exists in most of the problem. Sometimes it doesn't exist, but I want to tell you why, as the polynomial function or simple rational function, in that case you don't check that means a particular function which is defined from minus infinity to a particular point or particular point to infinity. Don't check. Simply only check at doubt point. Now there arises what is doubt point. Doubt point means that at which point function is separated. As you know that this function fx is categorized in 3 parts at x is equal to 0. That means if x is 0, if we take x is less than 0, then we choose fx is equal to mod x plus 1. If we take x is equal to 0, then we choose fx is equal to 0. If we take x is equal to greater than 0, then fx is equal to mod x minus 1. That means this is the doubt point. This is doubt point. That means you have to check necessary this doubt point. You have to check necessary at this doubt point. Otherwise, in most of the cases, limit exists. But further, still we have to check in each case, because this is your beginning classes for limits solution. Now, because there are 3 cases, as we know that 0 is only doubt point. That means definitely we have to divide in 3 parts: less than 0, greater than 0, and at 0. I want to write if case 1. If A is greater than 0, if A is greater than 0, then limit x tends to A, fx exists if limit x tends to A from left hand side of fx is equal to limits x tends to A from right hand side of x. That implies that you can write limit x tends to 0 fa minus x is equal to limits x tends to 0 from fa plus x. Can you write? Now there arises constant. What is the meaning of which function we can choose? As you know that I have chosen a is greater than 0. What is the meaning of this one? A is greater than 0. Suppose that you can choose any value. It doesn't say slightly greater than 0. It says a is greater than 0. If you choose h, suppose that a is any constant, just greater than 0, suppose that 2. Now it says you slightly less than 2. Slightly less than 2 means that which function? This function. Now you have to replace x by a minus x. That implies that limit x tends to 0. Limit x tends to 0. A minus x, that means x is replaced by a minus x minus 1 is equal to limit x tends to 0. If you choose a plus x, that means slightly greater than 1, slightly greater than a, slightly greater than a. In that case, again, we choose this function similar, because a is equal to 2 and 2 is x is greater than 2, because 2 lies in this interval. So we have to choose again this function. So it will be mod a plus x minus 1. Now you have to put x is equal to 0. If you put x is equal to 0, then because a is greater than 0, a is greater than 0, and x is very positive small quantity, definitely you can write directly. So you can put directly x is equal to 0, and it will be a minus 1 is equal to a minus 1. Why? Because you can put x is equal to 0, it will become a minus 1, and it will become a minus 1. So here limit x tends to a fx exists, because both will be same. Similarly, we have to check in second case when a is equal to 0. When a is equal to 0, then limit x tends to a fx exists if limit x tends to a left hand limit, right hand limit same, and this will be same. Now you have to choose function. It says that x is equal to 0, a is equal to 0. Now it says that slightly less than 0. Slightly less than 0 means that you have to choose this function. That means x is replaced by a minus that. So you can replace a by 0. Now you have to write mod 0 minus h minus 1, and it says to you slightly greater than 0. That means mod 0 plus h minus 1. Have you understood? If you take slightly greater than 0, slightly, sorry, there is plus. Now, if you choose by this way, you get what? It will be, if you put x is equal to 0, then it will be 1 and it will be minus 1. So, here limit x tends to f that doesn't exist. Why? Because RHL will be different. In third case, when a is equal to, in third case, when a is less than 0, that means for this function, you get different functions. Then in that case, you get a minus h, that will be less than 0. That means definitely you choose what? Mod a minus h plus 1 is equal to mod a plus h plus 1. Why do we choose it? Why do we choose? Because it says slightly less than 0. Slightly less than 0 means that a is negative. H is also positive, and already before h we take negative sign. In that case, definitely you can say that here it will be completely negative. If it will be negative, then you have to choose positive. In that case, you have to write it a plus h. If you put h is equal to 0, then it will be a plus 1. Similarly, in right side, if you put h is equal to 0, it will be again a plus 1. That means a plus 1 is equal to a plus 1. So here limit x tends to a exists. That means totally what is the conclusion of this question? If a is equal to 0, then limit fx at x is equal to 0 doesn't exist. Otherwise, for all value of a, limit x tends to a of fx exists. You can write. Now I want to write the whole conclusion clearly. For all value of a, limit x tends to a of x exists except x is equal to a is equal to 0. केवल x is equal to a is equal to 0 नहीं होनी चाहिए. इस पॉइंट को छोड़ except a is equal to 0. Now we take again next problem for you. The next question, find the left limit of the function f defined by f(x) equal to 5 minus x. Example 23. Find the left limit of the function f defined by f(x) is equal to root under 5 minus x as x tends to 5, and there is also additional matter in this question. Does the right limit exist when x is equal to 5? When x tends to 5? When x tends to 5, does right hand limit exist or not? Now, first we solve. Find the left hand limit at x is equal to 5. then you can say that limit, you can write LHL of fx at x is equal to 5 will be limit x tends to 5 from left hand side fx will be limit x tends to 0 from left hand side f5 minus x will be limit x tends to 0 from left hand side. Here x is replaced by 5 minus x, so you can put in fx directly in place of x 5 minus x. Now it will be 5 minus x. Now if you manipulate, you get what? Limit x tends to 0 root under 5 minus 5 0 minus plus x. If you put x is equal to 0, you get x is equal to finally 0. That means at x is equal to 5, LHL of x is equal to what? 0. Have you understood? Now, in this question there is also additional. Does the right limit of fx, does the right limit exist when x tends to 5? You have to write RHL of fx is equal to 5. It will be RHL and it will be RHL, it will be positive. Now you have to write positive and you have to write here 5 plus x and there will be minus 5 plus x. Finally you get the minus h. Now there arises a question. Root under minus h. H is a positive quantity and negative sign. Do you know there is no any real number which comes under root? That means, do you know about this number? Root under minus 2, root under minus 3. Does it belong in a real number family? No, it is a complex number. So you say about doesn't exist. About which? RHL. RHL of fx at x is equal to 5 doesn't exist because it gives say that number which is a complex number doesn't belong to family of real. Now we take again next problem for you. That will be 24. Sorry, 25. In the 25, it asks to if the function fx satisfy. If the function fx satisfies limit x tends to 1 fx minus 2 divided by x square minus 1 is equal to pi, then evaluate limit x tends to 1. This is good problem. This is how can you solve it? In this problem, if the function fx satisfies limit x tends to 1 fx minus 2 divided by x square minus 1 is equal to pi, evaluate limit x tends to 1 fx. How can you solve it? As you know that since limit x tends to 1 x square minus 1 is equal to what? 1 square minus 1 is equal to 0. As you know that if you take limit of denominator, then it gives 0. As you know that it is a division fx by gx, and you know that it can be separated limits fx by limit gx. If you get limit gx equal to 0, in that case it is not defined. As you know that in this portion its limiting value is equal to pi, that means definitely limit exists. What will be happen here? There will be definitely exist some factor in numerator which can be cancelled with denominator, due to which it occurs. In this case, definitely numerator should be also 0. In that case, it becomes 0 by 0, and after finishing one or two steps, you get your exact answer. So 0. So you can say that limit x tends to 1 fx minus 2 is equal to also 0. That means limit x tends to 1 of fx is equal to 1. True. Have you understood? I think you this conceptual portion is covered. Thanks all of you. In this class, actually your time you have today. I think your whole existence of whole class is completed, which is related to existence of limit, and you have to now practice your problems which is in your book, and thereafter I will again discuss some standard problems if you have any doubts, and you have to only I think evaluating limits and existence of limit there is no any difference, only differ by LHL and RHL, but I have already told you, you can during evaluating the limit you can check also, you can also find LHL, RHL, it depends upon you by which way you find the limiting value of fx at given value. Have you understood? Thanks all of you. I will again meet you in next classes. Bye.